So let us imagine that you were in Wuhan, and let us enable you to be able to detect an abnormal disease pattern and report it. So normally diagnosis is by pattern recognition. If an old lady slips and falls and has pain, swelling, deformity and loss of function around the hip, and you have a flexion reduction, external rotation deformity with shortening above the trochanter, then the pattern suggests that this is a case of fracture neck or fever. So if you detect an abnormal pattern, supposing you were in Wuhan and you detected cases of fever followed by abnormal acute respiratory distress syndrome, the first thing you should have done was to search in literature, and if the literature yields no such results or very few such cases, then you have detected a new disease. The next thing you do is make a checklist of the pattern you see or saw prospectively, that means forward in time, or retrospectively, that means backward in time. And if you find that in 5 patients of fever, ARDS was present in 4, then that is a very high or an abnormal association between fever and ARDS. So you now chart the number of patients with both fever and ARDS against time. And supposing you find a rising pattern, in week 1 there was 2, in week 2, 4, then 4 again, then 8 and then 10. Then supposing you find a rising pattern, then you become cautious and you report to health authorities. Now this is called as surveillance, and here you are acting like a sentinel or a chowkidar. So the situation with the sentinel is that you are here, the people who are reporting, you are being able to detect. But then there are many who have not reported and they are left undetected. Therefore, sentinel surveillance is important for early detection. But survey, that means studying everyone in this population, would give you the real results. So here, 3 out of 8 have reported only, and 5 you do not know anything about. So this is sentinel survey. Now there are many sentinels like you, 1, 2, 3, 4, 5, 6 doctors, and if all of them have started reporting to health authorities, they will go and do a proper survey. So when they do a proper survey, that means that they will diagnose fever plus ARDS in each member of the population. Let us say that the number of the population was 1000. So we'll see this jar and water experiment. Supposing this is a jar having 1000 cc's, and at present the volume of water in it is 20 cc. Now this is filling the water in. This is called as the filling station, and this is the draining station. So the rate of filling would be determined by filling minus draining. So if it is filling at, let us say, 2 cc's a minute and draining at 1 cc per minute, then the filling rate will be equal to 1 cc. Effective filling rate will be equal to 1 cc per minute. And to reach from 20 to 80, it'll need 80 minutes. So that is on the volume. Now let us convert it into the prevalence in the population. So what is prevalence? Prevalence in the population means 20 out of 1000 were found diseased. And at time t, 80 out of 1000 were found diseased. Therefore, if the time was, let us say, 1 year, that means in 12 months' time, 60 new patients occurred in this population. So, in 12 months' time, 60 occurred. Therefore, in 1 month, in 12 months, 60 occurred. Therefore, in 1 month, 5 will occur. Therefore, this 5 becomes the incidence rate of the new disease per 1000 population over 1 year period. Okay. So this is the formula. The volume at time t would be equal to volume at time 0 plus t into incidence rate minus attrition rate. Attrition rate means the drain, which means cured, migrated or died. And this becomes the prevalence rate at time t is equal to prevalence rate at time 0 plus time into incidence rate minus attrition rate. And that means 80 is equal to 20 plus 12 into x. 12x is equal to 60, therefore x is equal to 5. 5 per month is the rate of occurrence of new cases, provided that there is no cure, no migration, no death. That means the attrition rate is 0. If this is the incidence rate, if attrition rate is equal to 0. So if you have understood this, and if you find that there is a rising incidence rate over time, then you have to determine the cause. You have to report. You have to contain the problem. The China response was that it stopped all internal flights from Wuhan, but it allowed all external flights. So Italy found out that there was something abnormal, so they stopped flights from Wuhan. So the China organized a demonstration in northern Italy, which meant hug the Chinese. And so as they started hugging the Chinese, there was a tremendous amount of an explosion of the COVID pandemic in Italy. So the first thing is contain, and contain honestly. Don't allow all the flights to go into the world, and only contain the flights that go into your own country. That was wrong. So here usually, since it is an infective problem, think of the agent, think of the environment, think of the host. And here the spread was airborne, therefore precautions against airborne were able to control the disease, like masks. Then host immunity, because 80% of as the disease kept on spreading wider and wider, more and more people became immune, and that is called as herd immunity. So if this virus is not able to find all are immune, then it is not able to find a host where it can get transmitted, therefore the disease will die. So by the herd immunity it was controlled, and herd immunity was added by a vaccine campaign. So you were able to treat the host and make them immune. So this is how you have to classify or think about the interventions, and some interventions are possible and some were impossible. For example, you couldn't have dealt with the agent anyway. couldn't have genetically modified the agent not to affect human beings, not to attack the ACE receptors, not to have receptor binding sites. So this was not possible. So you tackled the environment and you tackled the host. Now, you determine the cost effectivity of each intervention. For example, vaccine, you have to spend 30 rupees per case prevented, and ivermectin you have to spend 20 rupees per case prevented, and mask you have to spend 50 rupees per case prevented. So naturally the most cost effective strategy is 20 rupees per case prevented. So you have to search out strategies and choose the most cost effective combination for your policy. So there is policy and there is practice. Practice is by the population and policy is by the health authorities. And both combine to tackle a new disease occurrence over time, which can become a pandemic. I hope you have understood these numbers.